Hello everyone. Today we will learn about a very important topic in thermodynamics. It is called the adiabatic process. Don't worry, I will explain it in a very simple way. After this video, you will clearly understand what adiabatic process means, how it works, and where it is used in real life. So let's begin. An adiabatic process is a process in which no heat enters and no heat leaves the system. That means there is zero heat transfer. In short, heat gained is zero. Heat lost is zero. In equation form, Q equals zero. But here is something interesting. Even if heat is zero, temperature can change, pressure can change, volume can change. Why? Because of work done. Look at a bicycle pump. When you push the pump quickly, the air becomes hotter. Did you add heat from outside? No. The temperature increased because of compression. That is an adiabatic compression. Now pull the pump quickly. The air becomes cooler. That is adiabatic expansion. So remember, fast compression makes gas hot. Fast expansion makes gas cold. The first law says, heat added equals change in internal energy plus work done. In equation form, Q equals delta U plus W. Now for adiabatic process, heat is zero. So the equation becomes delta U equals minus W. This means if the gas does work, its temperature decreases. If work is done on the gas, its temperature increases. For an ideal gas, the main adiabatic equation is PV power gamma equals constant. Gamma is written as a symbol like this. Gamma equals Cp divided by Cv. For air, gamma is about 1.4. You do not need to memorize numbers now. Just remember this formula works only for ideal gases. On a pressure and volume graph, the adiabatic curve is very steep. It is steeper than the isothermal curve. Why? Because no heat enters the system, so temperature changes faster. Now let's see where adiabatic process is used. In car engines, air is compressed very fast. Heat does not escape, so compression is adiabatic. That is why engine temperature increases. In jet engines, air is compressed before fuel burns. This compression is almost adiabatic. Efficiency depends on it. In refrigerators, gas expands rapidly. Temperature drops. This happens because of adiabatic expansion. When hot air rises, it expands. Its temperature decreases. Clouds form. This happens due to adiabatic cooling. A fire piston works like this. Air is compressed suddenly. Temperature rises rapidly. Fire starts. This is also adiabatic heating. In real life, a perfect adiabatic process does not exist, but we try to achieve it by very fast operation and good insulation. We call such cases practically adiabatic process. Many students think no heat means no energy change. That is wrong. Work can change energy. Some think temperature remains constant. That is wrong again. That happens in isothermal process. Adiabatic means heat is zero, not temperature. Remember this. Adiabatic means no heat, only work. Q equals zero, but work does not equal zero. Let us revise quickly. Adiabatic process means no heat transfer. Temperature can change. Formula is PV power gamma equals constant. Used in engines, aircraft, refrigerators, atmosphere. If this video helped you, hit the like button. Comment adiabatic. Subscribe for more engineering concepts made easy. Thank you for watching.